Good day, my dear students. Congratulations for reaching this far. Today, we shall discuss about hyperbolas. In this short video, we shall focus on the different characteristics of hyperbolas. But before that, let's recall the things which we have discussed in the previous videos. In the first video, we have discussed how to keep our pets safe by estimating the perimeter fence while having a walk with our pets. In the second video, we have learned about parabolas and how this concept was used in the game Angry Bird. In the third video, we have talked about the reflective property of ellipse and how it was used in the medical field through lithotripsy. Have you wondered about what is in store for you in this video? Did you know that in the 1940s, many have been saved because of a system which allows voyagers to determine whether they are on the right track or not? That system is called LORAN. LORAN, also known as long-range navigation, is a hyperbolic system which uses radio signals to determine the exact location of a ship in the vast ocean or an aircraft in the limitless sky. Just imagine navigating without LORAN. But do you know how this system works? To answer that, let us study the different characteristics or properties of hyperbolas. Hyperbolas are like pairs of parabola, which may open sidewards or upward and downward. Technically speaking, a hyperbola is the set of all coplanar points in which the difference of the distances between the foci and the points on the hyperbola is a positive constant. We call the two fixed points as foci. Let's say we get a point and label it P sub 1. Getting the difference of its distances from the two foci, we will get a constant that is equivalent to A. Let's get another point on its lower left. Let's label that P sub 2. Getting the difference of its distances from the two foci, we will get a constant that is equivalent to 2A. Let's get another point on the lower right. Let's label that P sub 3. Then, getting the difference of its distances from the two foci, we will still get a constant that is equivalent to 2A. Now what if we consider a point on the upper right and get the difference of its distances from the two foci? The result is a positive constant that is equivalent to A. You might be wondering what this A represents here. You will discover as we discuss further the characteristics of hyperbolas. We call the turning points on the hyperbola as vertices. These set of points are the closest points among the points on the hyperbola. The line segment connecting the vertices is called the transverse axis, while the line that bisects the transverse axis and is perpendicular to the latter is called the conjugate axis or the minor axis. We said a while ago that a transverse axis connects the vertices. In other words, the vertices are the endpoints of the said axis. On the other hand, the endpoints of the conjugate axis are called covertices. The point of intersection of the two axes is called the center of the hyperbola. From these two axes, we can form a rectangle whose sides are congruent to the length of the axis respectively. We call this as the auxiliary rectangle or the central angle. This is very helpful, especially in manual graphing. because from the diagonals of this rectangle, we can graph the asymptotes of the hyperbola. The asymptotes are the line at which the hyperbola gets closer and closer to, but never intersects them. Graphically, we can say that a hyperbola is a pair of parabolas. So just like parabolas, a hyperbola has also a pair of latus rectum. Just like ellipses, hyperbolas also have variables. We use a for the distance of the vertex from the center. We use b for the distance of the covertex from the center. And lastly, we use c for the distance of the focus from the center. These three variables are related to each other. We can equate c squared equals a squared plus b squared. To find the eccentricity of hyperbolas, we also need to get the ratio of c to a, and take note that the eccentricity of hyperbolas is always greater than 1. The standard form of the equation of a hyperbola having a horizontal transverse axis is given by the square of x minus h all over a squared minus the square of y minus k all over b squared equals 1. While the standard form of the equation of hyperbola with a vertical transverse axis is given by the square of y minus k all over a squared minus the square of x minus h all over b squared equals 1. Compared to ellipses, where the position of the variable a is interchangeable, in hyperbolas we always have a in the denominator of the minuend. Just like the other conic sections, when the equation is in standard form, we can easily determine its characteristics. So, there's a need that all of us know how to transform equations to its standard form. But before we discuss that, let's have first checkpoint number 1 to assess how well you've understood our lesson.